Okay, so this is going to be a pretty quick lesson here. We're going to talk about complex numbers. This was actually part of your chapter 4 stuff. And what we're going to do is before the end of the trimester, I want to get back to the chapter 4 things and review them. So this is going to be a review of 4.6 and part of 4.8. The part of 4.6 that we're going to do in 4.8, it all ties together. So this is imaginary numbers and complex numbers, and some of you said that you hadn't learned this before. It's really easy, so we're going to go through this. This will be a one-day thing, and then we're going to move on in Chapter 5. So the first thing that we're going to talk about here is we're going to talk about what an imaginary number is, and the first thing here is we need to understand is not all quadratic equations have real number solutions. In other words, if you're given, an equation like x squared equals -1, that has no solutions, because if we were to take the square root of both sides, we have the square root of a negative number, which will give us undefined in the calculator. And not to mention, read this reason right here, because the square of any real number is never negative. Well, that's true. You can never get the square of 5 to be negative. You can never get the square of -2 to be negative. So we're going to call, our first definition here is going to be called the imaginary unit I. It's defined as I equals the square root of -1. So I, whenever you see it in math or any type of math class, it will always be equal to the square root of -1. Notice, if we were to square both sides, when you square a square root, the square root is eliminated. So therefore, I squared is equal to -1. And that'll be important down the road, but not really with what we're doing today. So below you can see, this can be used to write the square root of any negative number. So as you see here, what happens is that anytime we have the square root of a negative number, what happens is we separate that number. So for example, if I give you the square root of -15, that is the same thing as saying the square root of -1 times the square root of 15. So therefore, because we just defined that the square root of -1 is I, that is the same thing as saying I root 15. That's exactly why you see this. As soon as you see the square root of -r, that is equal to I root r. Okay? So that's going to help us with what we're doing later. So let's just get right into it. We have this one page of notes. It'll take us a few minutes to get through it. Solve the equation 3x squared minus 7 equals -31. So you would solve this equation or start solving it just like you would anything. Because we only have these two terms, we're going to add 7 to both sides. So we're going to be left with 3x squared equals -24. Divide both sides by 3. And we're left with x squared equals -8. Now we take the square root of both sides. Now, one thing you have to remember that I know many of you don't is when you take the square root of both sides, you are left with x over here. But on the other side, you should be left with plus or minus the square root of -8. So let's continue on. X equals plus or minus the square root of -1 times square root of 8. And you don't have to do this step. If you know that this is going to be an I, then that's fine. You can just write it like that. So we are left with x is equal to plus or minus I square root of 8. Okay, but we're still not done. We always need to try and simplify our square roots. So this right here, the square root of 8, okay, I'm going to go move down a little bit here. So the square root of 8 can be written as the square root of 4 times the square root of 2. And if you notice, you know what the square root of 4 is. The square root of 4 is 2. So that is actually equal to 2 root 2. So now instead of writing plus or minus I root 8, we need to replace that square root of 8 with 2 root 2. So I'll write the answer in a different color here. So our final answer will be equal to x equals plus or minus. And then I'm going to put the 2 out in front, 2i. And then the square root will always come at the end, so square root 2. So that's that. All right, let's look at the next example. Okay, this next example is very similar, but now we actually have 3 terms here. And because we have 3 terms, we would either need to factor this, but now we're going to use the quadratic formula. So if you recall the quadratic formula, it is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So that means that you have to be able to identify your a, b, and c. So a is equal to negative 5, b is equal to 5, and c is equal to negative 7. Okay, so we're going to just start plugging these values into our quadratic formula. So we get x equals negative 5 plus or minus the square root of 5 squared minus 4 times negative 5 times negative 7 all over 2 times negative 5. Next line, all I'm going to do is go through and simplify this. Negative 5 plus or minus the square root of, and I'm going to go ahead and skip a step here. This is negative 115 inside there, and then we have negative 10 on the bottom. So continuing on to simplify this, we have x equals negative 5 plus or minus I root 115. So notice I brought the negative out to become I over negative 10. Now, we're going to do one thing here. Now, this normally would not be allowed, but it is allowed here because we have a plus or minus sign here. Because we have a negative here and a negative here, we can cancel those out because all it would do is flip these signs, and we're using both of them anyway, so it doesn't matter. Normally, you can't do that. Normally, if I give you a negative 5 plus 3 over negative 2, we can't just cross out these negative signs. It would have to change this sign as well. But as soon as you add both signs in there, it doesn't matter. Now we can get rid of those negatives. So I wanted to clarify that before we actually finish. So the actual answer here is going to be x equals 5 plus or minus I root 115. Little problems here, all over 10. Okay, and that's really all you need to know about imaginary numbers. You just need to know that when you have the square root of a negative number, what to do with it. Now, don't forget, always check to see if you can reduce your radical. In this case, we can't. 115, that's as reduced as it possibly can be. When you're reducing a radical, what you're looking for is you're looking for factors of the number that's under there that will be a perfect square. Okay, so we will work on that a little bit more. It's not going to be a huge deal one way or another, but like up here, 8 can be reduced into perfect squares, so that's why we had to do that. 115 doesn't have any factors that are perfect squares, so therefore you're done there. Okay, so that's it for this video. So we will work on this tomorrow, and then we'll move on to something different the next day. So we're only going to spend one day on this.